Hi folks, you might remember my recent video where I tore down an old 40 megabyte Commodore Amiga hard drive, and I showed you inside it and the technology on the board, of a hard drive that's a vintage, and I just thought it'd be interesting to tear down a more modern hard drive. So that's what we're going to do today. We're going to be taking this Seagate 320 gigabyte hard drive to bits. This drive has failed. It's just clicking when it's powered up, and if I'm totally honest with you, I'd say that 9 out of 10 laptops I work on that's got a hard drive issue, it's always a Seagate drive. They're so unreliable. I just would not recommend you use them for anything critical. At all. Hitachi drives and Samsung tend to be more reliable in my experience. To a lesser extent Western Digital, but Seagate are by far the most unreliable drives I have ever come across. So, like I say, my advice would be to steer clear for critical stuff. In fact, even for anything, just don't buy Seagate, in my opinion. Anyway, so we'll just go ahead and crack it open and have a look and see what's inside. So, from just looking at the physical drive itself, you notice that it is an awful lot slimmer than the old IDE drive that was in the Amiga. Of course, the technology, the components, everything nowadays is smaller, and obviously that ultimately results in the saving of space, and you can make your products so much more compact than the old ones. Right, so just quite a few screws there, 7 screws just holding this board on, and the board just lifts off. Okay, so on the board, this side is not populated whatsoever. There's some test points here, and possibly there's obviously provision for some sort of dual inline package. Don't know what that's likely to be. Maybe some sort of memory buffer. But okay, so we'll just take the insulation off. This is a insulation and a heat transfer pad by the looks of things. And on there we've got some various components, all of which are not, most of which I'm not sure what actually are. Of course, we'll have some. This is possibly, I've not googled any part numbers or anything, but I imagine this is some type of memory or some sort of buffer for the drive itself. A quad flat pack there, and some sort of BGA chip. Obviously this is all surface mount, including the SATA connector on the end. I believe this connector, don't quote me on this, I'm not sure, but on a sort of traditional IDE CD drive, certainly that would be an audio connector, direct audio onto the motherboard, or indeed a sort of PCI or whatever sound card. So I'm not sure if, clearly it's not a CD drive, but I'm not actually sure what that 4-pin connector's for. But yeah, so not much on there, just a couple of little inductors, very few passive components, and like I say, just a couple of sort of control chips and maybe a bit of memory on there. So that all goes on to the board just goes on, and there's these spring-loaded terminals here that just when the board's on, press onto these pads here. I don't know if you can see that on the board itself, but there's a sort of blue tinge to the contacts there. They have been making contact, so that's not the cause of failure of this drive. But interestingly as well, if you have had a drive failure, and you know it's not been dropped, and you're almost certain. I see there's a very obvious scotch marker, burnt marker, traces burnt, and you can't affect a repair on it. If you search eBay for the same drives, the same drive number and same firmware, the serial number obviously will be unique, but if it's the same type and same firmware, you can, and I have done it in the past on 2 occasions, managed to save a drive by just purely transferring the control board over to your faulty drive. So, if it's, let us say, a damaged control board, literally take it off a drive that you know that's working and put it onto the other drive, and you might just be able to save your data. Anyway, there's a little tip for you. So yeah, on here we've got a spring-loaded connector, which obviously drives the heads and bits and bobs inside. We've got a motor connector here, and that's again coming through this connector here inside. In fact, I tell a lie, the motor's actually onto these 3 pins here. Right, so we'll try and actually get into the drive now. And most drives nowadays have torque screws on, obviously to stop you getting in and having a look. As I mentioned in my last drive, as soon as you open a drive, unless you're in a clean air environment with uber filtration on the air, this drive's going to be knackered as soon as you crack the lid on it. Right, so it's all the visible screws are out, but there is another screw securing it, and I don't know if you can just make out, but you probably can't. But normally there's a screw under the label, and I'm guessing it's here, just by the way the sticker looks. Yep, and there we go. And there we have it. So, in fact, it's exactly the same fault as was in the Amiga drive. I don't know if you can see that. Well, you can see that actually. That there is the head off the arm there. And what this drive, like I said, it was clicking as it was powered up, and as the drive spins, it clicks. Anyway, we'll take it down further. We'll take this off here. And we'll take the top magnet out. Excuse me. Again, little safety warning, if you're not used to using these before, these neodymium magnets can be extremely powerful and can nip your fingers if you're not careful. So on here, let's see, we've got our control connector there, and what that's doing is controlling these coils on the head within the magnetic field. So you've got a neodymium magnet below and above this coil, and of course when a signal gets put into here, it will move the drive appropriately, just like a solenoid or similar. What else have we got in here? Got another little sort of safety catch, if you like, which prevents the heads from going onto the platters themselves. So once that's out, then the heads can travel freely across the discs. Yeah, and that's just so that when it's not connected, you know, or not powered, you know, if it drops it, there's an element of protection to stop the heads from scratching the plates themselves. Okay, folks, we'll see if we can take the platters out themselves. So just a single taut screw in the centre, and then this little disc holding it on. Now see, the Amiga was a single disc. This drive is 2, and that each of those is holding 160 gigabytes of data. Now I don't know if we're going to be able to take this down much further. Just bear with me. I should see if I've got a suitable bit to hand. Nope. Nearly there. Still a bit. Right, that might do it. Just take the, I'll just cut this actually. Yep, so there's a sandwich of arms. So we've got a coil, and we've got our pickups, and you know, we're two heads. Well, what remains of them, as you saw, the part of the heads was stuck to the drive. And then lastly, in here we've got the other side of the connector, which goes onto the flat flex. Yep, so it's just that little connector surface mounted onto the flat flex cable, and another neodymium magnet. And that's all that's in it. So yeah, I thought that might have been interesting for you. Yeah, don't take it your hard drives to bits, because they'll never work again. And just remember that top tip, that if your control boards failed, get one with the same firmware, the same part number, same firmware number or revision, and transfer the board over, and there's a chance you'll be able to save your drive. Anyway guys, I hope you found that interesting. If you did, give us a thumbs up. If you didn't, don't bother. And I'll see you soon for another video. Cheers, bye bye.